To finish up our chapter on tissues, or the study of histology, we're going to look at a little about tissue repair. Now, this will be more of an overview of tissue repair, as there's a lot of different steps and chemical processes that go into it. But let's start with the idea of inflammation. When something starts to be repaired or healed, there's going to be an inflammatory response that kicks in. Now, this inflammatory response is non-specific. It means it doesn't matter what caused it. From something bumping into the skin, something cutting the skin, something stabbing the skin, you can have a tear. Whatever the damage was, inflammation will occur, hence non-specific. You have the idea of quick. Sure, it inflames sometimes moments after the injury occurs. So this can be a very quick inflammatory response coming in after the tissue was damaged. And it occurs at the site of injury. That might sound like it's a no-brainer. Of course, it occurs at the site of injury. But think about this one. Sometimes with other reactions, you have the point of injury, but then the aspect occurs further up in a joint or somewhere else from where the initial impact was. So the inflammation starts at that point of injury, but it can spread out to further locations depending on what's going on. So inflammation, inflammatory response. The immune response. The immune response will be specific. What that means is, depending on what happened, your immune system will respond accordingly. So if it was a bacterial infection, you'll have the white blood cells respond for a bacterial infection and try to get rid of the bacteria. If it was simply a cut without bacterial infection, they're looking at more, we'll look at get rid of the dead cells. If it was more of a viral problem, you have a viral response. If it was more along the line of parasitic worms or some other parasite, you'll have that type of response. They're specific to the type of infection, but then even more specific to what the infection is. What type of bacteria is that? What type of virus? What type of parasite? So the immune response will be a specific response based on what occurred. So inflammatory is general, immune is specific. And it has a taking of a longer period of time. Well, if you're trying to be specific, you have to figure out first off what is there. Once you figure out what's present, then you can respond. So that's why the immune response will be a longer or more delayed response compared to the inflammatory response. It needs to figure out what's there and then make sure it has the machinery to fight what it found. So a more specific response, the immune response. So we're looking at this repair process. One of the things to keep in mind is the cells need to divide and migrate. The idea is, once damage has been done, you have to make sure that you can then regenerate new cells, the idea of mitosis, to put new cells in the place of the damaged ones. Your body will clear out and remove old dead cells or damaged cells. So this is the idea of replacing the cells. And the idea of migrate. Well, you have to make sure you get the white blood cells in, the nutrients in, and sometimes new cells in to certain locations. So we're trying to replace what's going on at times. Regeneration. Well, you're replacing the same tissue, sure. If you damage the skin, you're going to replace the stratified squamous epithelium, the part on top, with more stratified squamous epithelium. The surface below, the connective tissue, you want to replace it with areolar and dense irregular, but depending on the size of the injury, it might end up being more scar tissue than the dense irregular and the areolar. But you're trying to regenerate what was there, and if you can't have that, then you regenerate based on strength. More of a fibrosis we'll get to. So the fibrosis mentioned, that is the replacement if the injury site is large enough. If you think about a paper cut, you can slice right through your skin. It doesn't feel great, but usually when those heal up, you can't even see them because they're so thin and small. But a larger injury site, you might end up with a scar from. So that is the idea of fibrosis. That visible scar is the fibrosis occurring in the connective tissue. You're replacing what was there, areolar and dense irregular, with a different tissue that creates the scar tissue. So we're looking at this replacement to increase strength and seal up that damaged site. Unfortunately, it's not exactly the same material if the damaged site is large enough. So let's get back to that inflammatory. Now we start, the very first thing, again, was inflammation. Inflammation can occur from many different aspects. You can see I have 5 different chemicals down here, from histamines to kinins, prostaglandins, cytokinins, and leukotrienes. We're not going to go through each one of those. Be aware they're all inflammatory. I'm willing to bet you probably have heard of histamines before. Histamines are antihistamines. Your body produces histamines and they cause inflammation. When you take an antihistamine, that medication you're taking is trying to prevent further histamine production or, and sometimes as well as, reduce the amount of histamines in your system. So by reducing or preventing further histamines, it will help to reduce the amount of inflammatory response. You're saying, well, I do that for allergies. Well, allergies are an inflammatory response. Just, you might not see the inflammation on your skin, but it's how it reacts in your nasal passages, or maybe your throat or your lungs. So you have different types of reactions from an inhalant that's an allergen versus one that you ingest that might cause problems in your throat or intestines. So that's what antihistamines try to prevent histamines. But all these can cause inflammatory response. Now you start looking at this one, effects of these chemicals. What do they do? Well, I said inflammation, sure. But to be more specific, vasodilation. Now vaso refers to vessel, so blood vessel. Dilation is open up. In the case of vasodilation, you're opening up your blood vessels, increasing blood flow. Secondly, increase capillary permeability. Well, the capillaries are the tiny little blood vessels that are all throughout your tissues. It's how all the nutrients and gases get into your tissues and then come back out. By increasing the permeability, it allows for more of these particles, whether it be nutrients, gases, or chemicals, to go through in and out of the actual capillaries. So it increases the exchange. Chemotaxis. Well, chemotaxis is a chemical trail. You have different cells in your body. Some of them are your white blood cells, for example. They can actually trace the chemical signature of other molecules. So they can start to follow a path of this chemical signature. So chemotaxis, the following based on a chemical signature. Diapedesis. Now diapedesis is going to be when your white blood cells leave your blood vessels. So these white blood cells can squeeze through the capillaries and go out into the surrounding tissues. This will allow them to go through phagocytosis of foreign particles or damaged cells or whatever needs to be destroyed. So the idea of diapedesis, leaving the blood vessel. Phagocytosis, well, you're eating, destroying. This is when cells are triggered to destroy or eat something. Might be an allergen, might be a foreign particle, might be a dead cell. But you're trying to get rid of it. And last but not least, pyogenesis. Pyogenesis is the formation of pus. So these inflammatory chemicals could trigger the formation of pus. You're thinking, well, what's the point of pus? A lot of times what it's doing is it's helping to isolate an area. Keep a certain chemical or pathogen isolated inside of that area that's filled with pus. So it's kind of a containment system sometimes. Other times it's just simply trying to get things out of there. So there's different functions depending on what's going on in your system. But any of these or all of these can occur under inflammatory conditions. So let's start looking at the actual process that occurs. So first off, the trauma caused the release of histamine or other inflammatory chemicals. Next up, the capillaries then dilate. That histamine or inflammatory chemical triggered the dilation of the capillaries. By dilating the capillaries, you increase the permeability. You can see all these little dots here. These are basically leaving the capillaries. So it's going through diapedesis. You're letting white blood cells out, but also by increasing permeability, you're letting more ions and particles out. So your white blood cells, your antibodies, your different clotting proteins are all leaving to go to the site of damage. The point is they're targeting where this damage was. So this is helping by increasing the blood flow and permeability to stop the blood loss because you bring in more clotting proteins, more white blood cells to fight off infection. You're trying to get that area under control. So ultimately, the goal is to form that blood clot. So when you form the blood clots, you now stop blood loss. You're holding the edges together, which is important because you have to hold those edges together for the new cells to grow. If the edges keep changing in width, your body doesn't know how many cells to put in there to seal it up and regrow. So this creates a stationary environment so your cells know how many layers and how many cells to fill in the gaps. And it helps to isolate the injured area. By putting that blood clot in place, it creates this own internal environment of just that spot where you have the damaged cells. You might have a bacterial infection. You might have who knows what in that location. It isolates it, allowing your body to respond and get rid of what needs to get rid of and repair what needs to be repaired. So it's all about getting your body set and ready to go for the healing process. The exposed part, that's called a scab. So that's what you see on your skin surface. That scab is just the top coating. A lot of things are going on underneath. So that blood clot that was there needs to be replaced with this granulation tissue. So you can notice that as this fills in, this granulation tissue up here is helping to fill in the space, fill in the gapping. So it's all going down all the way deep into the tissue. You'll notice that around that granulation tissue, there are a ton of capillaries. These areas on both sides, here and here, they're filled with a high amount of capillaries, which allow more blood flow, more nutrients, more proteins, pretty much everything that's needed to repair that tissue. So you have this kind of pinkish tissue because it's so engorged with blood because of all the capillaries. The fibroblasts are hard at work making new collagen and a new matrix. But that's in the dermis of the skin, where there was connective tissue. The fibroblasts will not be in the top parts, the epidermis, where you have the epithelial tissue. So those fibroblasts are only working down here, where you have the actual dermis. The fibroblasts are not working up here, where you have the epidermis. So it only works in one location. Macrophages, we mentioned they are phagocytotic. Well, they're here to not only eat any dirt or debris or pathogens, but they're also vital to the wound because these macrophages destroy and remove the damaged cells. The cell fragments are left over. You have to get rid of all the damaged or dying cells before you can put new ones in their place. So the macrophages are very important in the wound healing to get rid of anything that shouldn't be there, plus anything that's damaged or dying. So let's regenerate now. We know the fibroblasts were making the collagen. They're starting the regeneration process. The surface epithelium, that's up here, that's being regenerated with the same tissue. That means that was keratinized stratified squamous epithelium. It's going to be replaced with keratinized stratified squamous epithelium. So this top layer of your skin will be the same exact tissue replacing it, as long as the wound isn't too large. Sometimes some very large wounds, you just can't replace it on your own and need some help from a skin graft or something else. But as long as it's a normal size, like a slash or cut or something small, usually your skin can replace it. It helps to grow under the scab. So right here, that's your scab. It's the top layer. Below it, you can see how it's kind of pieced in there. That's the replacing epithelial tissue. So it grows layer by layer up underneath the scab. As it's growing, you're constantly having macrophages breaking down that scab to get rid of the pieces as you put layer upon layer underneath it. That's why it's important not to try to pick off a scab before it's ready. The tissue underneath is still healing, it's still growing. You have to give it time to fully heal before you pull off that scab, or you might just simply reopen it and cause all the damage over again. So it's getting thicker and thicker until that scab naturally falls off. We've mentioned fibrosis before, but now if you notice on this image, here is where the fibrosis is. It's in the dermis where the connective tissue is located. Never quite matched the original. That's why in here it's more gray meshwork compared to the pink on the outsides of it. So this idea is your body's way of saying, you know what, this was damaged, had enough damage here, we're gonna make it really strong so you don't damage it again. Sure, does that mean you can still damage it? It's possible. But a lot of times it's your body's way of trying to repair itself stronger than it was before. By the time you're said and done, fully regenerate epithelium should be the same thing. All this up here is the same stratified squamous. All the fibrosis down here doesn't quite match, but it's still connective tissue. And that's where the underlying scar can be. Now, that scar tissue can lessen over time. Sometimes 5, 10, 15, 20 years later, a scar won't quite look the same as it did previously because your body's constantly regenerating, making new layers, and replacing tissue. So you might end up having a lesser amount of a scar as you go on through the years. So that's the idea of tissue repair, starting with the inflammation. Immune system's a little more specific, and then you have to go through the whole process of getting all the proteins and the clotting factors, getting the cells in there to clear things out, phagocytosis of the dead material, a lot of things going on. But it's all there to replace and regenerate that tissue. So that's histology, the different tissues, and then some repair and replacement.